You see, angles. Angles are two types. What are the two types? One is a plane angle, and the second one is a solid angle. These two types of angle we specially study up to the 12th standard. One is a plane angle, another is a solid angle. It is understood that whenever the ray is there, this is the ray of light, this is another ray, or we can say two straight lines. An angle between them, this is a theta. What is this theta is called? It is called as a plane angle. Plane angle. But what is solid angle? Solid angle means what? And where we utilize it? What is the purpose of solid angle? That is, we are going to understand today in this video. Suppose this is some solid. It is a surface. This is a solid surface. And you are observing the solid surface from here. Suppose these are your eyes. From here, what you are doing? You are observing the solid surface. So your vision not going to single point. Your vision is going to each and every point of the solid. It is going here, as well as it is going here, as well as it is going to other corner here. So like this, it is going everywhere. It is, you are able to see the complete solid. When you are able to see the complete solid here, then here you are making some angle between the first to last, and you are able to see each and every part of the solid. Then you are making some angle here. Some angle is placed here. So that angle is called as a solid angle. You are looking at three-dimensional object. So solid angle related to three-dimensional objects. And solid angle is either denoted by symbol this, or it is denoted by omega. So solid angle is something related to three-dimensional measurement. Suppose we have a surface. The area of the surface is dA. dA is the surface area. And here is a point O. From point O, the solid being observed. And it is assumed that each and every part of the solid is being seen. And here is a angle. This is a symbol of solid angle here. And so here is a, let us say, d omega. And so this is the direction of area vector. And this is the direction normal vector. An angle between them is theta. Then what is the formula for solid angle? The formula for solid angle is d omega equals to dA cos theta divided by r square. So this is the formula for solid angle. So solid angle depends upon what you are seeing, what is being observed, which solid is being seen. And so, and the angle between the normal and area vector. So it is a area vector. And what is R? R is nothing but distance of this solid from the point of observation. So this is R. R is the distance between the solid and the point of observation, that is equals to R. So solid angle given by d omega equals to dA cos theta upon r square. What is the n cap here? N cap is nothing but unit normal vector. So here we can write the solid angle equals to dA n cos theta divided by r square. So this can be written as the dot product. The dot product of what? dA dot n cap divided by r square. So this is the basic formula for the solid angle. So solid angle becomes d omega equals to d vector dA dot n cap divided by r square. N cap is nothing but unit normal vector. Now suppose I consider a complete spherical body. This is a sphere, not circle. So when you consider the sphere, now let us consider small surfaces, many small surfaces. So the entire sphere is having large number of small surfaces like this. So these are all small surfaces, and this is the center. So this is the first solid angle. Let us call it as a omega 1, and this is the second solid angle. Let us call it omega 2, and this is the third solid angle. Call it as a omega 3, and so on till the last one is a omega n. So if you add all these solid angles, this is a closed surface. Spherical body is a closed surface, and if you add all these solid angles, this has to be equals to 4 pi. Therefore, solid angle subtended at the center of sphere, solid angle subtended at the center of sphere due to entire spherical body is equals to 4 pi. Suppose the given body is not spherical in shape, it is any other arc shape like this, but it is a closed body. Now consider point O here, and again we will consider the many small surfaces on this one. It is a three-dimensional body, okay, and on this three-dimensional body we are considering so many small surfaces like earlier case. So in that case also, the total solid angle at point O, subtended at the point O due to entire closed body is equals to again 4 pi. That means it is not necessarily the body is a spherical body. This body can be any shape. Even then, the solid angle due to the entire body is always equals to 4 pi. I would like to clear one point. In both cases, the point O is inside the closed body. But suppose a case like this. Suppose I am having a cone. This is a cone, and this is a radius, and it is a semi vertex angle theta, and you want to find out the solid angle at the point O. So solid angle at point O. Point O is nothing but vertex of the cone. Vertex of cone. So solid angle at the vertex of cone is nothing but given by omega equals to 2 pi multiplied by 1 minus cos theta. This is the formula. So here it is not equal to 4 pi. So when the body is totally closed and you are calculating the solid angle from inside of the body, in that case solid angle equals to 4 pi. But you are not inside of the body, you are somewhere else, then solid angle due to that three-dimensional object, due to that surface, is something else, not 4 pi. How to denote the solid angle? The SI unit of solid angle is steradian, and it is short form is SR. Both are the small letters. S is small and R is small. So SI unit of solid angle is steradian. The way to use the solid angle. What are the applications? Applications of solid angle are many. So many there are. So many applications. Here I have written only the few of them. First of all, in electrostatics. while using the Gauss theorem to find out the normal electric induction. There we use solid angle. This is the first use. Second is in case of optics to find out luminous intensity. Luminous intensity due to object, due to the, like example, bulb, or like any shining object, any object which is providing light. You need to find out the luminous intensity. To find out luminous intensity, we use the concept of solid angle. And the third one is the, suppose you are observing moon from the surface, from here, from the surface of earth, you are observing the moon, and you would like to know what is the size, what is the area, surface area of a particular part of the moon, or particular part of the, like sun, or any other, like some planet. So how to find that? So that can be obtained easily with the help of solid angle. And heat transfer mechanisms, and in chemistry also want to find out the what is the size of the metal ligands. So that is also possible with the help of solid angle. There are the more application. These are the few I have written here, so that you will get how important, you will get an idea how important is the solid angle. So examination point of view, like JEE and medical, IIT JEE and the NEET examination and other competitive examination, the concept of solid angle is very important. Even though it is from the chapter 1 in 11th standard, but it plays important role in scoring your marks in the IIT JEE and the NEET examination. So I request all of you do this topic thoroughly and don't neglect this topic, and do some problems and keep the notes ready related to solid angle. That's all in this video. Meet you again with the next topic. If you feel that you are benefited by this video and you want to see more such videos in coming future, so subscribe the channel, because if you subscribe, then we are get motivated ki somebody is liking our presentation, somebody liking our the information provided. So we are motivated and we want to create more and more videos. So your subscription, your liking, and is very important for us to motivate us ourselves to create more better quality videos with good content. So meet you again with next topic. Till then, wish you good luck. I hope you enjoyed this video. Once again, like, share and subscribe the channel. Bye bye. Wish you good luck.